Welcome all. Today's new session is total internal reflection TIR. How light can reflected back in the same medium, that phenomena we'll see. Today's concept is total internal reflection. Students, already we know that when a ray of light travels from rarer medium to denser medium, ray of light bending towards normal. And similarly, when a ray of light travels from denser medium to rarer medium, the ray of light reflected away from the normal. Again, what point we have learned? When ray of light travels from rarer to denser, angle of incident always greater than angle of reflection. On other hand, when ray of light travels in denser to rarer medium, always angle of refraction greater than angle of incident. By taking this concept, let us take how light can reflected back in the same medium. See, to understand concept of total internal reflection, or simply we are calling TIR, total internal reflection. To understand this concept, let us take water medium. In water medium, the ray of light travels from water to air or from water to rarer medium. See here. To understand this, I can take, this is water medium. Denser medium I will take. This is nothing but denser medium. Are you following me? This is denser medium, right? And consider it is nothing but level of water. This is level of water. Following me? This is nothing but water. Level of water is there. So this water has refractive index how much? Water has refractive index of what value? 1.33 nearly. We know that this water has refractive index of what value? N1. Water is a denser medium. What you can call? This is a denser medium. Fine. Consider it is a air medium. It refractive index is N1. Right. Consider the ray of light which is goes from the water perpendicularly. We know that when ray of light incident perpendicularly, ray of light never refracted. How it is? Let us take. This is nothing but the point from which the ray of light goes. Shall I take this point? I can take this point is nothing but O point. Now a ray of light goes from denser to rarer perpendicularly initially. How this is? Consider this is nothing but one ray of light. This ray of light goes perpendicularly in this direction. This is the direction of ray of light. This ray of light never deviated. Already we know. Let us consider one more ray of light incident at an angle I. See here how it is. Now let us take one more ray of light. This is nothing but one more ray of light incident at this point. Consider the ray of light incident at point A. In what direction? This is the direction. Ray of light goes from O to A. See here, the perpendicular line drawn at point of incident we are calling normal. And this becomes angle of incident. This becomes angle of incident. Right? We know that when ray of light travels from denser to rarer, ray of light deviated away from the normal. How it is? This I can call angle of refraction. In this case what happened? Always angle of refraction greater than angle of incident. Now thing is, if angle of incident increases gradually, angle of refraction also increases. See here, let us take one more ray of light. This is A ray of light. Now shall I take one more ray of light? Consider nothing but one more ray of light. This is nothing but OB. OB is nothing but one more ray of light. Incident at point B. Perpendicular line drawn at point of incident we are calling normal. Right. This angle, shall I take? This angle is nothing but angle of incident. I can call this angle of incident is I dash. Again, when angle of incident increases, gradually angle of refraction also increases. This angle of refraction I can mention as R dash. What is the meaning of this? As angle of incident increases, gradually angle of refraction also increases. But at a particular angle of incident, the refracted ray which is greatest along the surface. How it is? Look at me. One more ray of light I will take. From this point I will take again. This is nothing but one more ray of light incident at this point. Let us take one more ray of light incident at point C. Then how the refracted ray goes? Let us consider this is the refracted ray. How it is going? Refracted ray goes along the surface. Again shall I take? perpendicular line drawn at point of incident, this we are calling normal. Then at this angle, gradually at this angle, what angle? This angle I can take IC. At a particular angle of incident, here this angle of refraction becomes, how this angle of refraction becomes? This becomes 90. I can define one angle. This angle I can call critical angle. Critical angle means when ray of light travels from denser to rarer, ray of light grazes along the surface. At a particular angle of incident, the ray of light grazes along the surface. This angle I can call critical angle. See here. What is IC here? This IC I can call critical angle. Critical angle. See here. This critical angle, how to define? Look at it. The angle of incident in the denser medium for which angle of refraction is 90 degree. What is critical angle? Angle of incident in the denser medium for which angle of refraction is 90 degree, that angle is called as critical angle. Look at me. How to define? The angle of incident in the denser medium. Angle of incident in denser medium. Angle of incident in denser medium. Denser medium. For which angle of refraction is 90 degree, is called as critical angle. Is called as critical angle. Right thing? Then, if the angle of incident greater than critical angle, there what happens? See here, this IC becomes angle of incident. Here what happens? I'll take one more ray of light. From this point again I will take same ray of light, but angle of incident can be greater. Are you following this? This is nothing but one more ray of light, this ray of light going along OD. Right thing? Look at me here. Again I can take normal, perpendicular and drawn at the point of incident, we are calling normal. So this angle I can call, this angle shall I take, it is I double dash. This angle of incident I double dash greater than critical angle here. If angle of incident greater than critical angle, then this ray of light not reflected, not refracted. Instead, this ray of light can reflected in the same medium. How it is? This ray of light can reflected back in the denser medium along the direction of DE. Along the direction of DE. See here. Wherever angle of incident greater than critical, the ray of light not refracted, instead ray of light is reflected in the same medium. If ray of light reflected in the same medium, then this phenomena we can call total internal reflection. How to define total internal reflection? See here. The phenomenon of bouncing of light in the same medium when ray of light travels from denser medium to rarer medium. This phenomena we are calling total internal reflection. How it is? The phenomenon of complete reflection of light in the denser medium if angle of incident greater than critical angle. Angle of incident greater than critical angle, this we are calling total internal reflection of light. Very simple. How it is? Gradually as angle of incident increases, angle of refraction also increases when ray of light travels from denser to rarer. At a particular angle of incident, angle of refraction is 90 degrees, that angle I can call critical angle. If the case angle of incident say I double dash greater than critical angle, then ray of light can bounce back in the same medium. The phenomenon of complete reflection of light in the denser medium, if angle of incident greater than critical angle, this phenomena can call total internal reflection. Then to obey total internal reflection, what are conditions? Two conditions are valid if the ray of light can bounce back in the denser medium. See here. Now point is conditions for TIR. Conditions for TIR. Conditions for TIR. Total internal reflection. Conditions for TIR. To obey, the ray of light can bounce back in the same medium if angle of incident greater than critical angle. What is first condition? To obey this condition, ray of light must travel from denser medium to rarer medium. To obey total internal reflection of light, what is first condition? A ray of light must travel from denser medium to rarer medium. See here, first condition, to obey TIR, light ray must travel from denser medium to rarer medium, from denser to rarer medium, from denser to rarer medium. First condition. Second condition, to reflect ray of light completely in the denser medium, angle of incident must be greater than critical angle. In this case, what happened? This angle of incident I taken as I dash must be greater than critical angle. Second condition, angle of incident should be greater than critical angle. Should be greater than critical angle. These are two conditions. Should be greater than critical angle. These are two conditions for total internal reflection of light. Simply, light must travel from denser to rarer and angle of incident must be greater than critical angle. Now we'll see what is relation between critical angle and refractive index. Relation between critical angle and refractive index, that we'll see. See here, already you know what is meant by critical angle. Look at me. Next concept is relation between next concept is relation between critical angle and refractive index. Relation between critical angle and refractive index. Critical angle and refractive index. See here. To understand this concept, again you will take two medium. One is denser medium and second one is rarer medium. How to take? See here. Let us consider two mediums are separated. Say this is medium separated, I can take it is nothing but xy, right? This medium, what I can call this medium, I can call denser medium, right? Denser means higher refractive index represented by n2, and what I can call it is rarer medium, it has refractive index n1. To obey critical angle, what should be condition? Ray of light must travel from denser to rarer. Look at me. I define critical angle like this. When ray of light travels from denser medium to rarer medium, let us consider this is nothing but one ray of light. Let us consider this ray of light is PQ. When ray of light incident at point Q, this is normal, and the ray of light can refracted along the direction of QR. So this angle of incident in the denser medium, for which angle of refraction is 90 degree. Angle of refraction is 90 degree. This we are calling critical angle. How to define critical angle? Angle of incident in the denser medium for which angle of refraction is 90 degree. So for this one, let us apply Snell's law of refraction. How it is? ratio, I mean this angle we are calling angle of refraction. Are you following this? Ratio of sine of angle of incident to sine of angle of refraction is constant, right? Refractive index of rarer medium with respect to denser medium. Refractive index of rarer medium with respect to denser medium. Are you following? Now, here I can take angle of incident equal to critical angle and angle of refraction. Angle of refraction equal to 90 degree. I is equal to IC and R is equal to 90 degree. Right thing. Then again what it becomes? Sine of IC whole divided by sine of 90 is equal to N1 divided by N2. N1 divided by N2. See here. How to take? Here N1 is the rarer medium, its value equal to 1, and N2 is equal to denser medium, its value is equal to N. Because rarer medium in which value, refractive index which value is 1, that we are calling rarer medium. Look at me. Then sine 90 is 1, sine 91, then what it becomes? Sine of IC, sine 90 is 1 equal to, N1 is equal to 1, N2 is equal to N. Then finally what you got? So sine of critical angle is equal to what value? Refractive index. Sine of critical is equal to reciprocal of refractive index. I mean, if refractive index increases gradually, what is critical angle? Critical angle should be decreased. Critical angle should be decreased. How it is? The critical angle and refractive index both are reciprocal to each other. The material which has high refractive index, for that critical angle is very smaller. If critical angle very smaller, always angle of incident greater than critical angle. When total internal reflection of light takes place, when angle of incident greater than critical angle, then only total internal reflection of the light can take place. Are you following me? See here, diamond always it brilliance in nature, because diamonds has a high refractive index. Diamond has a high refractive index and critical angle should be very smaller. Wherever critical angle should be very smaller, always angle of incident greater than critical angle, so that in the diamond always total internal reflection of light can take place, so that the diamond always brilliance in nature. That is only the one reason diamond has brilliance nature. How it is? Diamond has a high refractive index and critical angle should be very small. Wherever critical angle should be very small, whatever ray of light incident, that ray of light angle always greater than critical angle, so that light can bounce back in the same medium. Multiple reflection can take place. That is nothing but total internal reflection of light. Other than this, total internal reflection has lot of application. Let us discuss one by one applications of total internal reflection of light. One of the application of the light, that is mirage. Application of TIR. See here. Next concept is application of TIR. Applications of TIR, total internal reflection. So first application we will see, that is mirage. 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 What is mirage and how the mirage can appear, that we will discuss in detail now. See here, mirage is an optical phenomena appear due to refraction and total internal reflection of light. Initially, how to define? The optical illusion appeared due to refraction and total internal reflection of light. How this mirage can appear? Before that, already we know Earth consists of different layer of different optical density. I mean, Earth consists of a different air layer. Each layer has a different refractive index. We know that near the Earth's surface temperature is very high. Due to temperature very high on the earth's surface, refractive index is very smaller, because refractive index mainly depends on temperature. As temperature increase, refractive index must be decrease, right? So that earth consists of different layer. Temperature of the earth gradually decreases with the altitude, so that the upper layer has lower temperature, higher refractive index, and the earth surface, the layer which is near the earth surface, which has lower refractive index due to high temperature. Then see here how different layer can exist on the earth surface, that we'll see. Look at me. So how mirage can appear, that we'll discuss now. Consider this is nothing but earth surface. Are you following? This is the surface, right or wrong? This earth consists of different air layers. Different air layers are available. Look at it. This is nothing but different air layers. Different air layers can exist like this. This has refractive index say N1, it has refractive index N2. What about refractive index N3, refractive index N4, like this. Refractive index of this layer greater than this layer greater than this layer, and it has lower refractive index. Right thing. We know that when ray of light travels from denser medium to rarer medium and angle of incident greater than critical angle, always the light can reflect in the same medium. I mean, this layer has a higher refractive index, it is denser medium, it is rarer medium, again it is rarer, this is rarer, this is rarer. As compared to this one and this one, it is rarer medium and this is denser medium, because this layer has higher refractive index, it has lower refractive index. Now, if you compare this one and this one, N3 and N2, N2 has rarer medium and N3 has denser medium. Again, if you compare N2 and N1, so this becomes denser and this becomes rarer. Mirage means the inverted image is appeared on hot days, hot summer days. In deserts or in hot summer days, always images appeared as a inverted. That is nothing but mirage. How mirage can appear, that we'll see. Look at me. Consider on the earth surface. On the earth surface, consider any one tree is available. Look at me, this is the tree. Simply I can call. Consider it is a tree that is available on the earth surface. Simply I will take. This is nothing but tree. Right? We know that earth consists of different layers of different optical density. See here. When ray of light, and consider he is the observer. Observer stands on the earth surface. Consider he is the observer. Look at me. He is the observer. This observer stands on our surface. Look at me. He is the observer. When the ray of light travels from denser medium to rarer medium, when ray of light travels from denser medium to rarer medium, and angle of incident greater than critical angle, ray of light bounces back in the same medium. How it is? Look at me. Consider the ray of light travels from denser. I mean, it is denser, it is rarer. It is denser, it is rarer. The ray of light, consider it is travel from denser medium to rarer medium like this. So consider at this point, angle of incident in the denser medium greater than critical angle, then ray of light can bounce back in the same medium. How it is? Look at me. Shall I take here? He is the observer. He is the observer stands here. Or I can take one more ray of light like this. See here. He is the observer. Observer stands here. The ray of light which is travel from denser medium to rarer medium like this, when angle of incident greater than critical angle, always the ray of light can bounce back in the same medium. In what medium it comes, in that medium it goes. Right? But when this observer sees this refracted ray, the ray of light can meet somewhere. At this point it can meet. How it is? Look at me once again, I am explaining. When ray of light comes from denser medium to rarer medium at angle of incident greater than critical angle. Consider angle of incident greater than critical angle, so that the light can bounce back in the same medium. This is total internal reflection. When this observer sees this refracted ray, where it meets, it can meet at this point. So that image of this tree, how it appeared? Image of this tree can appear here. Right thing? Image of this tree can appear here. Are you following? This is nothing but image of the tree. It can appear like this. What is mirage? The inverted image can appear during hot summer days. That optical illusion we are calling mirage. Simply the optical illusion appeared due to total internal reflection of the light. This we are calling mirage. Then after mirage, one more application will, that is nothing but optical fiber. How optical fiber works and what are uses of optical fibers, that we'll see now. See here. After this, one of the applications of total internal reflection is optical fiber. Look at it. Now we will discuss what is optical fiber and how it works. In simple way, I am going to explain that. Look at it. Next application of total internal reflection is optical fiber. Initially, I will draw the diagram of optical fiber, then later we will explain in detail. Look at it. How the structure of optical fiber looks like. See here, this I can call optical fiber. The inner part, this inner part we are calling core, and this outer part we are calling cladding. Right. See here. Simply, optical fiber mean the device which transmit light along any desired path without loss of intensity of light. That fiber we are calling optical fiber. How it is? The device which transmit the ray of light along any desired path without loss of intensity of light, such a device we are calling optical fiber. Then how it works? The optical fiber works on total internal reflection of light. Total internal reflection means if angle of incident greater than critical angle, always the ray of light bounce back in the denser medium. That phenomena we are calling total internal reflection. Then let us see simple construction. See here. Optical fiber consists of two surfaces. One we are calling core of higher refractive index. This surface we are calling core. This second called core. This surface having higher refractive index. The higher refractive index surface core, it is surrounded by cladding which has a lower refractive index. Two surfaces are there. One I can call core and second one we are calling cladding. The core having higher refractive index and cladding surrounded by core, that we are calling, that has lower refractive index. To avoid loss of intensity of light, I mean to avoid the loss of light and for safety purpose and for strength, the core and cladding are enclosed in a plastic jacket. This core and claddings are enclosed in a plastic jacket. The optical fiber made in such a way that wherever angle of incident, wherever ray of light can incident, always angle of incident must be greater than critical angle. How it construct? This core constructed in such a way that whatever ray of light incident at any place, angle of incident always greater than critical angle. We know that wherever angle of incident greater than critical angle, total internal reflection can take place. See here how it is. Consider the ray of light. I can take simple ray of light I will take. See here. This is one ray of light. This is one ray of light incident at this point. At this point, angle of incident always greater than critical angle. Angle of incident always greater than critical angle. So that how it happens? Ray of light can bounce back at this point. Right thing. Again, wherever ray of light incident at this point, angle of incident can greater than critical angle. Again, at this point, angle of incident can critical angle. Total internal reflection takes place. Then how the ray of light can comes? Ray of light can comes like this. I mean, wherever ray of light incident, always angle of incident must be greater than critical angle. Like this, the ray of light can transmit along any desired path without loss of intensity of light. Then what are uses of this optical fiber? Optical fiber mainly we are used in optical communication system. Where we are using optical fiber are used in optical communication system. Optical communication. One of the use of optical fiber. Optical fibers are used to send audio and video signals. See here, used to send audio and video signals. Audio and video signals. Similarly, these optical fibers are also used in endoscopes to view internal part of human body. To view internal part of human body, this optical fiber can take uses. See here, optical fiber can use to view or used in endoscopes. Endoscopes are helps to view internal part of human body. Similarly, for optical decoration, optical fibers also used. I mean, to transmit any optical signals, this optical fiber can use. To decorate the table lamps, to decorate the house, the optical fibers also used. I mean, for any optical communication nowadays, the optical fibers are used. Actually, this optical fiber has bundle of optical fibers are available. Those optical fiber helps to transmit any signals from one place to another place without loss of intensity of light. So that lot of applications are there. These are few uses of optical fiber. So this is construction and working of optical fiber along with some uses. Remaining concept we'll see in the next session. Thank you.